All right, guys, in this lesson today, we're going to learn how to balance redox reactions all the way through. You know, last time we talked about balancing half reactions. Now we're going to take both half reactions and totally balance the whole reaction. This stuff is a little complicated. So to help you out, I've got some rules for balancing redox equations. We're going to do the redox, balance them today in acidic solution. So the rule sheet that I just passed out, and if you're watching the video, you're going to have to use these rules, 1 through 6 here, all day today. So let's go through them. And in fact, I want you to write something on your rule sheet. I really should have put this as number 1, but in order to write the half reactions, we need to assign oxidation numbers. So let's put that here. Assign oxidation numbers. That's really step number 1. So hopefully we are good at that. Hopefully we know how to assign oxidation numbers to different atoms. Okay, then we're going to write the half reactions. We reviewed that in the last video. Okay. Step 2, balance the atoms other than the oxygen and hydrogens. We're going to balance them by just putting a coefficient so that they're balanced. Step 3, we're going to balance the oxygens by adding water. So if one side needs more oxygens, we're going to do that by adding water. Step 4, we're going to balance the hydrogens by adding H+. So if one side needs more oxygens, we're going to do so by adding H+. Remember, this is in acidic solution, and H+ ion is what makes things acidic. Step 5, we're going to balance the charges, so the charges on each side, the left side and the right side, by adding electrons. Okay, we'll show you how to do that. And step 6, we're going to make the number of electrons equal on both half reactions. So the electrons are going to be equal on both half reactions, and then we will add the half reactions together to get our full balanced equation at the very end. Sound good? Okay, stick with me today. This is I'm going to try to go slow and explain step by step, but it does get a little bit complicated. So I've got 3 practice problems that will be included in this video. Let's start with practice problem number 11. Okay, so let's go through practice problem 11 together. Okay? Practice problem 11 says balance the following redox reaction in acidic solution. Here's the reaction. Okay? First thing we need to do is assign oxidation numbers. What's the oxidation number for Cl minus 1?
0.
If it has a charge and it's monoatomic, it's equal to the charge. Okay, so it has a minus 1 charge, it's minus 1. Oxygen is always what? Minus 2. How many do I have? 4, so that's a minus 8. I have a minus 1 charge here, so it's got to be equal to a minus 1. What does the manganese have to be? Plus 7. I've got one of them, so it is plus 7. Okay. Manganese plus 2, what's its oxidation number? Plus 2. It's equal to its charge if it's just by itself. Chlorine, and it doesn't have a charge. It's 0. It's a free element. Its oxidation number is 0. Okay, I'm going to take some time and just erase these numbers on the bottom. I don't want to get confused by these numbers on the bottom. Okay. All right. Now let's draw our brackets. Which one is seeing its oxidation number go up? Chlorine. Is that true? Yeah, it's going from a minus 1 to 0, so that's being oxidized. Which one is seeing its oxidation number go down or be reduced? The manganese. It's going from plus 7 to plus 2, so I'm going to put reduced here. That's what reduction is. Its oxidation number is reduced. Okay, that is step. Well, we haven't written the half reaction. So step number 1, what does it say?
Write the half reaction.
Write the half reaction. So over here, I'm going to write the oxidation half first. Okay? A little bit different this time. I want you to include everything. So Cl minus. Make sure you get the charges. A lot of students will make a mistake by not including and bringing down the charge. Cl minus goes to what?
Cl2.
Cl2. Okay. Now, I know that the atoms aren't balanced yet. We've got 2 chlorines here, 1 here. We're not going to worry about that. We're just going to go step by step. I know that the charges aren't balanced. I don't have electrons yet, but it didn't say to do that yet. That's what's being oxidized, so that's it. Okay. Let's go to the reduction half. Okay. What's being reduced here is all of this. So I need to include all of it in my half reaction down here. So let's put MnO4, and it has a minus charge. And that is going to Mn plus 2. Okay. So now that we're balancing the whole reaction, I want you to include everything that's in this reduction part. Include it all. Okay. So that's step 1. What's step 2, guys?
Hold on, I'm not done with step 1. I can't see the board.
Can't see the board?
It's okay, Alvin.
Okay. What's step 2? Balance the atoms other than oxygen or hydrogen. Okay. Chlorine is an atom other than oxygen or hydrogen. How many chlorines do I have on the right side? 2. How do I fix that on the left? I need a coefficient of 2 right there. Okay, that's balanced. Okay, let's go down to the bottom one. Manganese is an atom other than oxygen or hydrogen. Is it already balanced though? 1 manganese, 1 manganese. Okay, we're done. What's step 3?
Add oxygen by adding H2O.
Okay, balance oxygens by adding water. Are there any oxygens in this half reaction?
No.
Nope, so we're done there. Are there oxygens in this half reaction? There's 4. So which side needs water?
Left side. Right side.
The right side, if I'm going to balance it, right? So put plus H2O. How many waters would I need in order to get the oxygens balanced? 4. Yeah, there's 4 oxygens here. I better have 4 here. The only way to do that is with a coefficient of 4 in front of the water. Okay, step 3 is done. What's step 4, guys?
The hydrogen.
Balance the hydrogens by adding H+. Are there any hydrogens in this half reaction?
No.
Nope, so we're good. Are there any hydrogens in this half reaction?
Yeah.
How many?
4, 8.
8 on the right side. How do I get to 8 on the left side?
Probably plus 8.
Yeah, I need to put some H pluses over here. How many of them?
8 of them.
8 of them. Okay, very good. So now my hydrogens are balanced. Let's go to the next step. Step 5. What does it say?
Take it out.
Good. Balance the charges by adding electrons. This is a step that always confuses students. So watch how we do this. What's the total charge of this guy?
-21.
Well, it's -1, but how many do I have?
2.
So it's a what?
-2.
-2. I'm just going to make a little note of that. This side's -2. What's this side?
Minus nothing. 0.
Isn't it 0? There is no charge. So which side needs electrons and how many?
Right side needs 2.
Right side needs how many?
2.
2 electrons. Okay. Now I'm going to scribble these out. I don't want them to confuse us later on. Okay. Let's go to balancing the charges on the bottom half reaction here. What's the total charge from this guy?
Plus
+8. What's the total charge from this guy? -1. So that is plus 7 overall. So I'm going to put a little +7. This side is what? +2 and +0. So this side is just +2. Which side needs electrons and how many?
The left side is 5.
Left side needs 5 electrons. Sorry, it's kind of curved up there. So I'm going to erase these because that will balance out my charges now. Okay, step 5 is done. What's step 6 say?
Make number of electrons equal.
Make the number of electrons equal on both half reactions. Okay, now on this half reaction we have 2 electrons. On this half reaction we have 5. What's the lowest number that both 2 and 5 will go into? 10. So here's how we get to 10. I need to times this top half reaction by what?
5.
By 5. Okay, and we're going to distribute that all the way through. So how many Cl minuses will we have? 10 Cl minus. Remember the charge, it stays there. Arrow, how many Cl2s? 5 Cl2s. Plus, how many electrons now? 10 electrons. Okay. Now what I like to do is draw a line through this top one. We've already distributed that 5 through there. I don't want to be confused by that one anymore. Draw a line through it.
Where'd you get the 5 from?
The 5, we just came up with that because we needed to have our electrons be 10. Okay. Now, in order for our electrons to get to 10 on the bottom, what do I need to times the bottom one by?
2.
Let's times this whole thing by 2. That gets me to 10 electrons. How many H pluses? 16 H pluses. How many MnO4 minuses? Don't forget the charge. How many Mn2 pluses?
2.
Good. And how many waters? 2 times 4 is 8 waters. Okay. Again, draw a line through this one. I don't want to be confused by it. We've already distributed that 2 all the way through. Okay, now let's read the last half of part 6 says, and then add the half reactions together. Now that we've got the electrons the same on both sides, we can add the half reactions together. Now watch how we do this. If I've got 10 electrons on the left and 10 electrons on the right, can I cancel them out? Yeah. So let's just cancel those out. Is there anything else I could cancel?
8 H2.
Is there something on both sides that we could cancel?
No.
Nope. That's it. So now what we're going to do is add these reactions together. So I'm going to take this one and add it to this one. So what do we have on the left side? So don't we have 10 Cl minuses plus 16 H pluses plus 2 MnO4 minuses? Don't forget to bring the charges with it, guys. That's everything on the left. Now let's list everything on the right that's not canceled out already. So we've got 5 Cl2s from right here. And then we've got 2 Mn plus 2s from right here. And I've got 8 waters. Okay. I think that this is my balanced chemical equation. I think. But when you get to this point, you should always go through and check. Let's balance it. How many chlorines here, guys? Help me out. 10. How many on this side? 10. Okay, so that's good. How many hydrogens?
16.
16. How many here? 16. How many manganese? 2. How many manganese? 2. How many oxygens? 8. How many oxygens? 8. Okay, so the atoms are balanced, but also with these redox, you've got to make sure your charge is balanced as well. What's the total charge right here? Minus 10. What's the total charge here? Plus 16. So what's my total charge so far?
6.
Plus 6. What's my total charge here?
Minus 2.
Minus 2. So now what's my total charge on the left side?
Plus 4.
Isn't it plus 4?
Yeah.
Okay. What's my total charge on the right side? Plus 4, because this one's 0 and this one's 0. This is plus 4. So do the charges balance?
Yeah.
Yes, they do. Always make sure that it's correct. You have a good way of checking yourself. Okay. Hey, isn't this good? This is fun, right?
It's not even.
Man, chemistry is awesome. I love this
I
stuff.
love chemistry.
I love this stuff. Okay, that's how you balance a redox reaction.
You said
One thing that I will always let you use, since it's your first time learning this stuff, is I will always let you use the rule sheet. Does it help you to go through it one by one, each step? Absolutely. That's what I would do. Yes, you can use the rule sheet on the test. Okay, stay with me. Hey,
Hey, how many of these questions am I going to test?
Stay with me. Okay, we got the answer correct, and we know that. Let's go to practice problem number 12.
Can we do it on our own? Oh.
Here's what I suggest. If you're watching the video, please go through and balance this redox reaction on your own. Okay, try it on your own. You got the steps out in front of you. Go through those steps individually, one by one, each step. See if you can balance this redox equation on your own, and then hit play once you have an answer. We're going to go through it here in a second, but please try it on your own first. Okay, so let's see how you did on practice problem number 12. The first thing that we need to do is assign oxidation numbers. So help me out here. This is a free element. It doesn't have a charge here. So what's its oxidation number? 0. Oxygen's always what, guys? -2. I've got one of them, so it's a total of -2. What does the chlorine have to be if this thing has an overall charge of -1?
+1.
Has to be +1. Okay. Oxygen is always what? -2. I've got 3 of them, so total is what? -6. Looks like this has a -1 charge, so if it's got to equal -1, what does the iodine have to be? +5. Okay. Chlorine has a -1 charge, so what is its oxidation number? -1. I'm going to take some time, guys, to erase all these numbers on the bottom. I don't need them anymore, and I don't want to get confused by them. Okay, now we can go to step 1, which says write the half reactions. Which one, guys, is being oxidized? We're seeing its oxidation number go up. Iodine. Okay, I agree. It's going from 0 to +5, so that one's being oxidized. Which one is seeing its oxidation number go down, Ethan? Cl. Okay. So if it's going down, that one's being reduced. Let's write the half reactions now. For oxidation, I'm going to put I2 goes to, what does it go to, guys? Do I need to include the oxygen?
Yes.
Yes, I do. So we're going to put IO3. Do I need to include this charge as well?
Yes.
Yes. IO3 minus. Okay, now let's write the reduction half reaction. Do I need to include all of this stuff?
Yes.
Yes, I do. So we've got OCl minus goes to what? Cl minus. Okay. Step 1 is now done. Let's go to step 2. Balance the atoms other than the oxygen and the hydrogens. Iodine is an atom other than oxygen or hydrogen. Is it balanced? I've got 2 on this side. How many on this side?
1.
Just 1. So how do I fix that? Put a coefficient of 2 right there, correct? Okay. Chlorine is an atom other than oxygen or hydrogen. Is it already balanced though? Yeah, so let's be done with that step. Step 3. Balance the oxygens by adding water. Okay? How many oxygens do I have on this part of the reaction? 6. So which side needs water? The left side needs water. How many waters? I need 6 waters there because now I've got 6 oxygen there and 6 oxygen on the right. So it's balanced. Okay, let's go to the bottom one. I have 1 oxygen here, but nothing over here. Which side needs water then? The right side needs water. How many? Just 1 water. We'll balance it. Okay, we're balanced. Let's go to step 4. Balance the hydrogens by adding H+. How many hydrogens do I have right here? 12. Do I have any so far on the right side? Nope. So which side needs the H pluses? The right side. How many H pluses? 12 H pluses. Okay, now my hydrogens are balanced there. Let's go to the bottom one. How many hydrogens? 2 hydrogens. Which side needs H pluses then? How many H pluses do I need, guys? 2. Okay. Okay, now my hydrogens are balanced. Let's go to the next step. Notice how we're going step by step by step, right? Number 5. Balance the charges by adding electrons. Now, this is the step that really is confusing for students. So please watch. We're balancing the charges. What's the charges of this guy? Shout it out, don't be shy. What's the charge here?
0.
0. What's the charge here? 0. What's the charge here?
-1.
By how many do I have?
2.
So what's a -2? What's this one?
Plus 12.
Plus 12. So what's a -2 plus 12?
Plus 10.
That's plus 10. I'm going to make a little note of that. Which side needs electrons and how many?
The left. 10.
The left needs 10?
Or the right, please.
Wouldn't that get me to a -10 on the left?
Right.
The right side needs 10. Yeah. Guys, always add your electrons to the side that's more positive. So how many electrons do I need? 10 electrons. Okay. And that gets my charge to 0 on the right, and it was 0 on the left, so it's balanced.
Is it you're adding the electrons on the side that's more positive?
Yes.
Because
Because the
the electrons
electrons are negative. You got it, Aiden. Good job. Okay, let's go to the second half reaction here. What's my total charge from this guy? Plus 2. What's my total charge from this guy? -1. What's plus 2 minus 1?
Plus 1.
Plus 1. So I'm going to make note of that. I was plus 1. What's my total charge over here? -1. Which side needs electrons and how many?
left side.
Left side. And how many? 2 electrons. How come I need 2 electrons there? Yeah, because it goes, if I only added 1, wouldn't that get me to 0? So there's 1, and then I need another 1 to get me to a -1. Okay, step 5 is done. Step 6. Make the number of electrons equal on both half reactions. So I've got 10 electrons here, and I've got 2 electrons here. How could I make them equal? What's the lowest number that 10 and 2 will go into? 10. How do I get this one to 10? I need to times this whole reaction by 5. So how many electrons do I have now if we distribute it? 10 electrons plus how many H pluses? 10 H pluses. How many OCl minuses? And that goes to how many chlorine? 5 Cl minuses. Plus how many waters? It's 5 waters. Okay, now we've distributed it. Let's cross this out. I don't want it to confuse us. Now, the second part of number 6 says, and then add the half reactions together. So we're going to add this reaction with this one. So I'm going to draw a line under it, and let's add them together. Now, when you get to this point, your electrons should do what? Cancel out. Do they? I've got 10 electrons on the left, 10 electrons on the right. They're gone. What else can cancel out?
Your hydrogens.
Yeah, H pluses. I've got 10 H pluses here, 12 on the right. Doesn't that take all of these?
Yeah.
How many do I have on the right then?
2.
Only 2. Okay, so I'm going to scribble that out and put a 2 right there. What about my waters? Can they cancel out? C. So 6 waters here, 5 waters here. Doesn't that take all 5 here?
Yeah.
And how many's left here? Just uno. Anything else cancel out?
Nope.
Okay, so now let's add them together. So I'm left with 1 water here, so let's don't forget about that, H2O, plus I2. That's everything on the left on the top one. What else is on the left here on the bottom? So we got plus 5 OCl minuses. Anything else on the left? Nope, so we draw our arrow. We've got 2 IO3 minuses. Remember, guys, to bring the charges down. A lot of you will make mistakes not doing that. Okay, I've got 2 H pluses. And then what else on the right here? 5 Cl minuses. Is that it? Okay, I think that is our answer. How can I make sure?
balance it.
Yeah, let's balance it. How many hydrogens here?
Those.
2. How many hydrogens here? 2. How many oxygens? 1 plus 5 is what? 6. How many oxygens here? 6. How many iodines? 2. And how many iodines here? 2. How many chlorines? 5. And how many chlorines here? 5. Are we balanced in terms of number of atoms? Yes. Now let's make sure we're balanced in terms of charge. What's the charge of water? 0. What's the charge of this iodine? 0. What's the charge of this one?
-5.
-5. So I've got a total of -5 charge on the left. What's my charge here?
-2.
-2. So -2
+2.
plus 2, because that's
Minus
plus
5.
2, and then -5. So are we balanced?
Here.
Yes. Okay, there's our answer. We know that is correct. Okay, who got that? Just curious.
After you get it, yeah.
Okay, guys, I've got one more to do with you. But really, I think you learn the best by trying it on your own first. So please hit pause on the video. Try to balance this one first on your own. Then once you get an answer, hit play. Again, the best advice I can give you on these problems is just go step by step through those steps, and you'll get the right answer at the end. Try it. Okay, guys, let's see how far you got with practice problem 13. See if you got the right answer. I'm going to go through this one kind of slow. We'll go through it step by step. The first thing that you need to do with this type of problem when you're balancing a redox reaction is to put the oxidation numbers above each atom. Guys, help me out here. Ethan, what's oxygen's oxidation number always? -2. Now, how many do I have? 7. So that's a -14. Guys, if it's a -2 charge overall, that tells you that it's got a sum to a -2. What number has to go here in order for this to make sense? Plus 12. But I've got 2 chromiums to get to plus 12. So what does each chromium have to be? Plus 6. Okay, this one looks complicated, but it's really not that bad. What's hydrogen? What's hydrogen's oxidation number? Plus 1. I've got one of them, so it's plus 1. Oxygen's always a -2. I've got one of them, so it's a -2. Hydrogen is always plus 1. I've got 5 of them, so it's plus 5. Is there a charge on this molecule? No, so it's got to sum to 0. What am I at so far? So 5 minus 2 is 3, plus 1 is 4. What does this have to be? Has to be a -4. But I've got 2 carbons. What does each carbon have to be? -2. Okay. Chromium plus 3. Now if it's just by itself, it's equal to its charge here, so it is plus 3. Oxygen's always a -2. I've got 2 of them. That's a -4. What does the carbon have to be?
+4.
Plus 4. Thank you. Okay, now I'm going to take some time to erase what we wrote on the bottom. These totals, they don't matter to us anymore, and I don't want to confuse us by having those numbers there. Okay, so we've assigned the oxidation numbers. Now we've got to see which one's going up in its oxidation number or being oxidized, and let's find out which one's being reduced. Which one's going up?
CR. Oh, no. C2.
Isn't carbon going up? Carbon is going from -2 to a +4, so that's going up, so that's oxidation. Which one's seeing its oxidation number go down or be reduced?
CR.
Yeah, the chromium here goes from +6 to +3, so that's reduction. All right. Now let's write our half reaction. Step 1 to our rules here says write the half reaction. So we've got our oxidation half. Guys, do I need to write this whole thing?
Yeah.
Yes. So let's put C2H5 OH. And that goes to what? CO2? Okay, let's write our reduction part. We have to write all of it again. Cr2O7 with a -2 charge. And that goes to Cr plus 3. Okay. Step 1 is now done. We've wrote the half reactions. Let's go to step 2. It says balance the atoms other than oxygen or hydrogen. Carbon is one of those atoms other than oxygen or hydrogen. There's 2 on the left. How do I get 2 on the right? Well, I need a coefficient of 2. Okay, let's go down to the bottom one. Chromium, there's 2 of them. How do I get 2 on the right side? I'll put a coefficient of 2. Okay, step 2 is now done. Let's go to step 3. Balance the oxygens by adding water. How many oxygens on the left side, guys? Just 1. How many oxygens on the right side? 4. So which side needs more oxygens? The left side. So I'm going to do that by adding water. Just put H2O. Now, how many waters will I need? Won't I need 3? Okay. And that will balance out to 4 oxygens on both sides. Okay. The bottom one, I have 7 oxygens here, 0 on the right. So which side should I put the water on?
On the right side.
On the right side. Okay, let's put H2O. Now, how many waters? 7 waters. Okay. Okay. Okay, so let's see what we've got now. We've balanced our oxygens. Our next step is number 4. It says balance the hydrogens by adding H+. Okay? Help me out. How many hydrogens do I have right here, guys? 6 plus how many more here? 6 plus 6 more is 12. Which side needs hydrogens? The right side. And how many H pluses? I need 12 of them. Okay? Now my hydrogens are balanced on the top one. Let's go to the bottom one. How many hydrogens do I have? 14. Which side needs H pluses added to it? Left side. And how many? 14. Okay. Now step 4 is done. Let's move to step 5. It says balance the charges by adding electrons. This is a step that a lot of students struggle with, so watch how we do this. Is there any charge with water? No. Is there any charge with this molecule? No. Is there any charge with CO2? What's the charge here? Plus 12. So if this side is 0 and this side is plus 12, how do I balance it?
Put plus 12 on the next
Good. I need 12 electrons over here because plus 12 minus 12 is equal to what? 0. And that's what this side was. Okay. I'm going to erase these numbers so they don't confuse me later on. Let's balance the charges on the bottom one. What's my total charge right here? Plus 14. What's my total charge here? Minus 2. What's 14 minus 2?
12.
So I'm at plus 12. I'm going to put my charges up here. Plus 12 on the left. I've got to balance them, so let's figure out what this one is. What's 2 times plus 3?
6.
Plus 6, and water is 0, so this side's plus 6. Which side needs electrons? Always put your electrons on the side that is more positive. Okay, so the left side is more positive, so how many electrons will I need?
6.
Yeah, I need 6 electrons over here. Okay, very good. Okay, now my charges are balanced. That's step 5. Let's go to step 6 then. Make the number of electrons equal on both half reactions. I've got 12 electrons on the top one and 6 electrons on the bottom one. How can I make them equal? How can I make them equal? Yeah, let's the lowest number that both 12 and 6 will go into is 12. So let's make this bottom one go to 12 electrons. I need to times it by 2, right? So let's distribute that 2 across. So I've got 12 electrons. Plus, how many H pluses?
28.
28 H pluses. Plus 2 Cr2O7. Do I need the 2 minus still? The charge? Yes, bring it down, okay? And then we're going to have 4 Cr plus 3s plus how many waters? 14 waters. Okay. Now what I like to do is just draw a line through this one so it doesn't confuse us. Okay, now we've made the electrons equal on both half reactions. Now the second part of step 6 says then to add the half reactions together. Okay, so what I do is draw a line under that bottom half reaction, and let's add these two together. When you get to this point, what should always happen? Your electrons should cancel out. Do they? 12 electrons on the left, 12 electrons on the right, so they cancel out. Now let's cancel anything else out that we can. Do my H pluses, can they cancel out? Yeah? I've got 28 H pluses on the left, 12 on the right. Won't that take care of all of these 12? What's 28 minus 12?
16.
So now I've got 16. I'll make a note of that. H pluses. Okay, what about my waters? 3 waters on the left, 14 waters on the right. Won't these 3 be lost? What's 14 minus 3? Isn't that 11? Okay. Anything else that we can cancel out here? No. Okay, so now let's add it up and be done and see if it's right. Okay, so I'm taking everything on the left side. So I've got C2, H5, OH. That's on the left. Now, what's on the left down here? We've got 16 H pluses plus 2 Cr2O7, the minus 2 charge. Arrow, now on the right we have 2 carbon dioxides and 4 Cr3 pluses. Okay. And then how many waters? 11 waters? Okay. I think that's our answer, but how can we make sure, guys? Yeah, let's see if they balance out, the atoms. How many carbons on the left side? 2. How many carbons on the right? 2. How many hydrogens on the left side? 6 plus 16, what is that? 22. How many hydrogens? 22. Okay, so that's good. How many oxygens on the left side? We got 1 here plus 14. What is that? 15? So I've got 4 here and 11. What's 4 plus 11? 15. So that balances. Chromiums, I got 4 here. I got 4 chromiums on the right. So we're balanced in terms of number. Now let's look at the balancing the charges. What's the charge of this molecule? 0. This one's plus 16, and this one's minus 4. So we got plus 16 minus 4. What is that? Plus 12. Let's see what's on the other side. 0. What's 4 times plus 3? Isn't that plus 12? And then water is 0, so that is our answer. Okay, we're done. Hey, that's the answer. How many of you guys got that? Good job. Hey, there's a lot to these problems, right? But I promise you, if you will take the rules for balancing these reactions and just go through them step by step, you will end up with the correct answer. To give you some more practice with this, guys. To give us some more practice, I've got a worksheet in the student workbook. It's called Balancing Redox Reactions in Acidic Solutions. So please turn your student workbook there. Balancing Redox Reactions in Acidic Solutions and get that done. And hopefully this video helps you.